Nick Matter is a Durban man who has designed and produced a ventilator in response to the COVID-19 crisis. It's a story of fantastic local innovation and collaboration. I spoke to Nick about his lockdown invention and his attempt to get it into production.
Yes, Greg, I am 57 and I studied mechanical engineering at UCT, and I graduated in 1987. Since then I've been doing mostly design engineering in industrial services and building services, which is the consulting company that we run. We started with the ambu bag and looked at how we could actuate that, and we formed a team very early, and then I started with a model so that I could be confident in cardboard of what the motion needed to be. And after, yes, a fair degree of experimentation, we realized that we could do this. We could actuate the bag. That is the ambu bag, and it has an inlet for air and for oxygen, and the outlet which goes onto a mask which breathes on the patient's face. And these are commercially available, and when you act on them, they pump and keep a person breathing. So we bought these and then turned this into part of the device. So that was our starting point. Okay, so this bag is actuated, which means that it's pumped automatically. And like a paramedic would do this to keep a patient alive, this machine does it automatically, but with the setting of the timing of IE. So IE ratio is the amount of time to breathe in and the amount of time to breathe out. Okay, so this device has a 12-volt DC motor, which is exactly the same as is used in windscreen wiper motors for motor cars. And we realized that it needed to be able to run off normal 230 volts plug sockets in a house or a hospital, and also that we could make it adaptable to run off a 12-volt motor car, cigarette connector or battery, or a battery from a solar charged system. So I was at UCT with Mark Watt, who then became Dr. Mark Watt, now an anaesthetist. And I called him and I asked him what a ventilator should do and if they were needed. And he said, yes, they will definitely be needed, and it should do three things. He said, make it volume-based, mandatory ventilator, and it must do 20 breaths a minute, and it must give 500 milliliter volume per breath, and have an IE ratio of 1:2. He said, only those three things, that's all it needs. That's what they would set up a patient on and keep them alive. So once we'd started on the track of developing the prototype, we realized who the players were needed, and we had to have electronics, electrical, mechanical, and construction of a casing. And so to do that, I engaged with Graham Gillett, who did the electronics module, Miles Walker, who helped with the drive and the coordination of the programming and the design of the interface, and I did the mechanical components, and from 0.5 glass, Mark Lewin built this casing for us. So that was the core of the team, the 4 members. 3 of us are engineers and 1 is a fiberglass specialist. And then we were guided all along by Dr. Watt, mainly as our principal and anesthetic advisor, and later on the ICU specialists, Dr. Kasanji, and as well as assistance from Wentworth Hospital, Dr. Naidu.
But even going forward, you can't get, or if it's specialised stuff, you're not going to get it. So,
and price also was an issue.
Yeah.
He didn't want to build a Rolls-Royce and pay Rolls-Royce prices.
Yeah.
One was looking at the end product at a reasonable cost, because electronics can get horrendously expensive, but with cost and performance in mind, and also reliability. I mean, it can't be a cheap piece of microcontroller that backs up after 6 months. This is looking after somebody's life, and so
We were looking for small motors, and a lot of small motors are DC motors, and a lot of DC motors are used in 12-volt motor car applications. So your window winders, your windscreen wipers, what else? Fuel pump, they all run on 12 volts. And this is a very strong, reliable 12 volt with a gearbox and motor.
I think it would be terrible if we sort of didn't attempt, and afterwards you think, well, maybe we should have actually built a unit that could have saved lives. Let's use the talents we've been given to, achieve something. Worst case, we would have tried, maybe we would have failed, that's fine, but now we've got something that's working. So.